Hey guys, welcome to our second video of your lesson tonight. We are going to do learning target C, which is solving right triangles using trigonometric functions. So we're going to be able to find missing side lengths and angle measures using trig functions. So I want to tell you we will be using a calculator. So please make sure, grab your calculator. If you don't have a calculator at home, use your cell phone that has sine, cosine, and tangent on the scientific calculator. Okay, so we have three examples here. We are going to be doing A and B and saving C for class. The instructions tell us to set up a trigonometric equation to find each missing side length. Round decimal answers to the nearest tenth. Okay, to set up a trig equation, we first look at where our angle is that we're talking about. And our angle is down here, this 24-degree angle. A trig equation involves either sine, cosine, or tangent. We're not going to use any of the reciprocal functions. So we are either going to use opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So we see the two sides that we're talking about. Obviously, we're looking for this side x right here, which is opposite of our 24-degree angle. We are given this side length 12, which is adjacent to the 24-degree angle. So we will be using tangent because tangent is opposite over adjacent. So let me just write that. Tangent of any angle theta is opposite over adjacent, and we're going to fill in what we know. First of all, we know the angle is 24 degrees. So we know the tangent of 24 degrees equals, and now the opposite side for us, that is x, that is what we are looking for, and the adjacent side is given to us 12. So we want to solve for x just using simple algebra skills. How would we get x by itself? Well, we would need to multiply both sides by 12. And so that would cancel, and I would have x equals 12 times the tangent of 24 degrees. So all you need to do is type that in your calculator. Of course, we talked about different modes in our calculator. Since we're measuring angles using degrees, you need to make sure your calculator is in degree mode. And you literally just type 12 tan 24. Okay, we are going to round to the nearest tenth. So once you've typed that in, you're going to get a decimal. And you're going to get approximately, then, rounding to the nearest tenth, you should get approximately 5.3. So we're going to say x is approximately 5.3. Okay, let's try B. Let's look at our angle. Our angle is 72 degrees, and that is right here. From that angle, we are given this side length 6, which is our adjacent side, and then this x is our hypotenuse. Using adjacent and hypotenuse, we know that that is cosine. So I'm going to write cosine of 72 degrees equals my adjacent, which is 6, over my hypotenuse, which is x. So I need to solve for x in this case. Unfortunately, x is in the denominator, so I have a couple steps. The first thing I'm going to do is multiply both sides times x, which cancels the x on the right. But now I have x times the cosine of 72 degrees equals 6. So I need to divide both sides by the cosine of 72. So in your calculator, you are going to type 6 divided by the cosine of 72 degrees. And you are going to round that to the nearest tenth. You should get approximately 19.4. Okay, that is finding missing side lengths. We can also use trig to find missing angle measures. So let's look at example 3. Set up a trig equation to find the missing angle measure. Round answers to the nearest tenth. Okay, so we see the angle that we're looking for has the theta in it. Same way we did up above, we identify what the sides are that are given to us. From this angle theta, we see 13 is across in the right angle, so that is our hypotenuse. And 12 is coming off of our angle, so that is our adjacent side. So that's cosine. Well, we don't know the angle measure, so we're going to write cosine of theta, but we do know adjacent is 12, hypotenuse is 13. Now what we need to do is we need to get this theta out of the cosine. So we use the inverse cosine. It is the second function of your cosine, and it looks like this. Cosine to the negative first. We're going to do that. Hold on, let me write that up here too. We're going to do that to both sides. And so technically, I'm going to put that right here too. Okay, so what I do when I do the inverse cosine, the inverse cosine and the cosine actually cancel each other out. And the only thing that's left over on the left side then is going to be theta. And on the right side, I want you to type in your calculator the inverse cosine of 12 over 13. So you're going to type second cosine 12 divided by 13. Okay, and we're going to round to the nearest tenth. You should get theta is approximately 22.6 degrees. So if you didn't get that in your calculator, check your what you typed in. Okay, let's do B. Letter B, we have angle theta here. Across from it is 4. That's our opposite side. Next to it is 13. That's our adjacent. That's tangent. So the tangent of theta equals our opposite 4 over our adjacent 13. And so remember, to undo this tangent, we're going to do the inverse tangent. So when I take the inverse tangent of both sides, I'm just going to be left with theta on the left. But on the right, I'm going to go inverse tan of 4 divided by 13. So you're going to type second tan 4 divided by 13. And you're going to get approximately 17.1 degrees. Okay. We are just going to do A for this one, and then the rest will be saved for class time. Example 4, set up a trig equation to find the indicated side length or angle measure given the diagram. Round decimal answers to the nearest 10. So basically what I'm saying is this is an arbitrary triangle. Not all triangles are going to be that the lengths aren't necessarily correct, but it's just showing you that from our side length, little a, we have angle A across from it, etc. So it gives us the information, we just need to fill it in. So in letter A, it says, given that B equals 45 degrees, C equals 5, find A. Okay, well, you guys might know this off the top of your head. Let's say, okay, here's B. I'm going to put 45 degrees there. And here's my right angle. That's C. Here's A. So side C across from angle C is 5. And I want to find A. Boom. Okay, so it looks like I'm finding a side length from this 45-degree angle. My 5 is my hypotenuse, and A is my adjacent. So that would be cosine. So I'm going to type cosine, or I'm going to write, cosine of 45 equals adjacent A over hypotenuse 5. Okay, so now to solve for A, I just need to multiply both sides by 5. And so A would equal 5 times the cosine of 45 degrees. And so that one you just type straight in. No inverse cosine because we know the angle. And once we type that in, let's try it out. And just straight in 5 cosine 45. You get approximately 3.5 for the length of A. All right, guys, I hope that you figured out how to use your calculators on that. If not, during class, we have all these other examples we're going to be doing, and we should be good to go. Have a wonderful night.